In this session, we will monitor crop harvesting during the pandemic using two tools, the ESA RACE dashboard and the EOBrowser platform. This is what we will do. First, an introduction to each of the two tools. Then a short case study in which we will see the context in the RACE dashboard, and we will complete the information it gives us with an analysis in the EOBrowser platform, where we will look for Sentinel-2 data and extract the time series to see the harvest and the impact that the pandemic has had on the harvest. Let's then go with the ESA RACE dashboard. RACE dashboard stands for Rapid Action on COVID-19 and Earth Observation. On the title of the slide, you can find the link to access the platform. Now, what are the objectives of this dashboard? First, to publish Earth observation information on the state of European economy and society. Second, to use European Earth observation, the Copernicus Sentinels, but also ESA third-party missions. Another objective is to leverage the capabilities of European companies and to use the latest AI-powered platform technology. There are many topics included in the dashboard, for example, climate, environment, economy, and agriculture, with indicators such as the concentration of greenhouse gases, the air and water quality trends, indicators related to industry, to maritime transport, construction, trade, traffic, and for agriculture, indicators related to crops such as asparagus, berries, etc. The dashboard uses data from multiple sources, which are listed here. For example, you find not only the Copernicus Sentinels and the ESA third-party missions, which I already mentioned, but also data such as population data, statistical data, or even anonymized mobile data. I'll leave you here the link to another session where this dashboard is presented more in depth. It consists of a PDF and also a video, and you can consult it for more information. There is also a broader collaboration with data not only in Europe, but from other areas of the world. And that is the result of the partnership between ESA, JAXA, and NASA. It is called EO Dashboard, and I'll leave you the link here if you want to visit it too. Let's now look quickly at the EOBrowser. The EOBrowser is part of the Sentinel Hub, and this here is the Sentinel Hub page. Let's get to know it a little bit more, to know more about the context of EOBrowser. If we go to the section on the right called About, and we click on it and we scroll down, we see several things. First of all, what is the Sentinel Hub? The Sentinel Hub is an engine to process large amounts of data, of satellite data. And it makes satellite data from Sentinels and other satellites available quickly and easily. So users can search, visualize, and analyze those data. Who is behind the development of the Sentinel Hub? It is a company called Synergize, based in Slovenia. And if we go down, we find a list of institutions that support the development of the Sentinel Hub, including ESA, but also the European Union, among others. Then on the left, in partners, we see that the Sentinel Hub includes data from the Copernicus Sentinels, among many others. There is also an FAQ with common questions if you want to know more. Inside the section called Explore, we find the EU browser section with all its information. We can see how to access it with the button called Start Exploring. And we also see two videos. One is a webinar and the other one is a showcase video. There is also a user guide. And going down, there is a part about the license. I mention it to emphasize that your browser is free and accessible for everyone. And in this part, it indicates how to reference them. If we use the images produced in your browser in the media or in press. So that's important to know, and then we will go up, we will access the browser itself. Right, so here we see the interface of your browser, and in the top right corner there's a tutorial to show us the interface. We can also choose the mode, education mode, which has default displays for some topics. There's also the location and the menu with many tools. Underneath we can zoom in, see the coordinates, and on the left there are some announcements. And finally, always on the left, there is the most important panel which allows us to search. For some of the tools we need to be registered, not for all of them though. The panel can be minimized and it gives us the choice among a list of themes, which would give us ready-made previews. And we can also choose the sensor and the date. And with this we will start our case study, first extracting some context from the race dashboard. We will follow a case study focused on the area of Huelva, located in the south of Spain, which is one of the areas with more greenhouses for fruits and vegetables. We will analyze what happened using the race dashboard and later on using the EU browser. Some more background information. The area of Huelva in Spain is an agricultural area full of greenhouses, as I was saying, where fruits and vegetables are grown and exported all over Europe. Workers often come temporarily from Morocco, and the harvest is stored in trucks for transport. During 2020, the lack of workers and the drop in demand caused a delay in the harvest and a drop in the amount harvested. On the race dashboard website, we navigate to the harvesting indicator, harvesting activity indicator on the left, which has data for Huelva, Spain. It displays the data in the map. Here we are. And by clicking on the icon, the data open and we can download them, or we can also read about them underneath. A specific example within Huelva is in a part called Laguna de las Madres. And it is one of the areas in southern Spain where there are most greenhouses. Those greenhouses export very large quantities of fruits and vegetables to the rest of Europe. And the data that were used to generate this graph come from Pleiades, because it has a higher resolution than Sentinel-2, and it was used to quantify the number of trucks that were present in the area of the greenhouses. These trucks are the ones that then transport the harvest. So let's go to the next slide to look a bit more in detail to the graph. So here we see the graph. On the vertical axis, we have the number of trucks. And on the horizontal axis, we have the months, so the time. There are two types of data. The data from 2019 appear in gray, and the data for 2020 appear in black. And then on top of the black bars, we see numbers in red or green that quantify how the how the number of trucks was compared to the number of trucks in 2019. Therefore, in red, it will indicate a decrease in 2020 compared to 2019, and in green, it will indicate an increase. And then the specific number quantifies that. So, looking at the graph, let's focus on the area of February, March, April, and June. In those months, there were fewer trucks in 2020 than in 2019. It means there were less trucks in 2020 than in 2019. However, in May 2020, there were more trucks than the precedent year. In other words, the harvest started later, and there was a peak of activity in May. This is what the data seem to suggest. This slide summarizes what we were just discussing. In February, March, April, and June, there were fewer trucks in 2020 than in 2019, so less harvested. And in May 2020, on the other hand, there were more trucks than in 2019. So this makes us think that in 2020, the harvest was smaller, started later, and had a peak of activity in May. All right, now we already know the context from the race dashboard, and we will go to your browser. And first of all, we are going to search for Sentinel-2 data. Now we are searching for Sentinel-2 data in Laguna de las Madres. We choose Sentinel-2 level 2A, and the date is in June, because at that time, some of the fields are still covered in plastic. We select one of the results, we visualize it, and here it is. We can see in a grayish color the fields that are still covered in plastic. Okay, we have now searched the data, so let's move into the data comparison. So we save the image as a pin so that we can access it quickly in the future if we want to. And we add it to the comparison panel, which is here on the top. We now repeat the search for an image of 2019 for the same area and for a date as close as possible to the date of our 2020 image. Then we pin the visualization and we add it to the Compare tab. This will allow us later on to compare the images. And here's how we compare them using this sliding tool. In 2019, the picture on the left, the greenhouse had already been dismantled after the harvest. And in 2020, not yet, the image on the right, probably due to the delay caused by the lack of workers during the pandemic. It is possible to share the pins that we generate via links or on social media. The tool is on the right here, and it will generate a small link that we can copy and share as we wish. And in fact, in the bottom part of this slide, you find the two links for the two images that are generated in this exercise. The time-lapse is a small animation, a GIF, with all the images of an area for a period of time. Let's see now how we create it for the year 2019. We have used the visualization panel, we went to the tool and we set the zone. We set the image search period and we focus on the harvest time from May ending in July to have a little margin. So you can adjust the percentage of clouds, and scrolling down we check that there are no clouds or artifacts in our images. We can also adjust the speed, and if we like it, we can export the animation. This is done for 2019, and we can do the same for 2020. It is a quick way to understand the dynamics of an area and to compare the images. So now let's look at the images of these time lapses, which I took as screenshots, and analyze the dynamics. The date is indicated at the top right of each image. Those two shown here are almost from the same day, but from different years. On the left, 2019, and on the right, 2020. Look especially at the yellow area, because later we will use one of the fields there to extract the time series. At the beginning of May, which is when those images were taken, there are not yet many fields where the plastic has been removed from the greenhouses. Now here we are in the middle of May, always on the left side from 2019 and on the right side from 2020. The images, as I was saying, are from the middle of May, and not much has changed yet. Everything is very much the same for both. Here we are at the end of May, specifically on the 22nd of May 2019, where they had already started to remove the plastic sheet in preparation for the harvest, whereas in 2020, such activity of removing the plastic sheets is much less visible. This is a delay in the start of the harvest. Now we are closer to the end of May, and as the end of May approaches, the difference is noticeable in the acceleration that occurred in May 2020. But in terms of the total area, I would say that more land has been harvested in 2019. It is useful to have data on the land and to understand the distribution chain, but it is difficult to obtain such data. Now here we are at the beginning of June, and it is noticeable that in the previous weeks for 2020 there was a peak of activity. It seems that fewer fields have been harvested than in 2019, for example in the north. This is the case of the area in the yellow circle. In 2020, it has not yet been harvested. Now, in mid-June, it seems that the activity is still accelerated compared to the previous year. It makes us think that perhaps they wanted to harvest in a hurry because of the insecurity of the pandemic, although local data would have to be taken into account. We are a bit closer to the end of June, and at this stage there are few differences. And in July there are also a few differences at this scale. Okay, so far we have searched for data in your browser and we have compared the data. Now let's extract the time series of both a pixel and a polygon. We can see in more detail what happened in a specific pixel. We look for an image at the end of the period in which we are interested, and we position the pixel locator. We point to it. And with this tool, we can extract the time series. If we're interested in a whole area, we will use this other tool, which will help us delimit the edges of the polygon to consider. And EOBrowser will average the values in each pixel to get the time series graph. As before, we use the NDVI, and the time series is accessed with the same icon. In this case, we will focus on a pixel and we will display the NDVI index. We go to the time series tool and we choose how far back in time we want to go, adjusting as well the percentage of clouds that we tolerate. We see that the harvest was done between the 12th and the 27th of April. We can export this result, and this has been done for 2019, so we should also repeat it for 2020. After doing that, we would obtain the results that you can see here. On the left side, the graph for 2019, and on the right side, the graph for 2020. In 2019, the crop that existed in the area where we placed the pixel was harvested sometime between the 12th and the 27th of May. We do not know the exact date because it depends on when a cloud-free Sentinel-2 image is available. In 2020, the crop was harvested between the 5th and the 10th of June. Now, since it is possible to download the time series, for example, as an Excel, that is a chance for you to improve the visualization, to adapt the visualization to something that suits your needs. In this slide, you can find the coordinates of the pixel. On the other hand, if you are interested in extracting the time series of a polygon, I'm leaving here the coordinates of the polygon, meaning the string that you would need to copy to import the same exact polygon as I used in this exercise. If you do that, if you extract the time series of that polygon, you would obtain the results that you can see here summarized in this slide. On the left side, the one for 2019, and on the right side, the one for 2020. Now we can see that the pattern is similar to what we had when we extracted from a pixel. However, the influence of the clouds is somewhat less present. The data are averaged. Okay, this is the end of this small and easy exercise. We have had an introduction to the race dashboard, to the EO browser. We have looked at the race dashboard for context of our case study, and then we have used the EO browser to search data, to compare the data among themselves, and to extract time series of a pixel and a polygon. Thank you very much for your attention.